All right, guys. So for this first round that we're going to go over, we're finding inverses algebraically. And remember, a big idea when we're finding inverses is that everything just kind of switches, meaning the x's and the y's are going to switch. So if I give you an equation, the first thing I want you to do is, instead of function notation, just label this y. Then you're going to switch the place of x and y. So I'm going to write x equals 2y minus 5. Then my job is to just get the y by itself. So I'm going to add 5 to both sides and then divide by 2. I do not care if you leave it as x plus 5 over 2 equals y, or x over 2 plus 5 over 2 equals y. What I do care about, though, is since we started in function notation, we want to end in function notation. So since this is the inverse, I'm going to write f inverse of x equals x plus 5 over 2. And that's what we're going to do for each of these problems. We're going to switch the x and the y and solve for y. So on this next one, the first thing I want to do is multiply by 5 on both sides to undo that division. So now I have 5x equals negative 15 plus 3y. I'll add 15 and get 5x plus 15 equals 3y and divide by 3. Okay. Again, you could, on the last one, just write everything over 3, but I like dividing it by 3 this way because 15 can be divided by 3 nicely to give us 5. Again, we started in function notation, so we're going to end in function notation by using our inverse of x notation. Okay. Last two. Again, just switch the place of x and y and solve for y. I need to get rid of this negative out in front, so I'm going to divide by negative 1. And when I do that, x divided by negative 1 turns into negative 1x. Negative 1 divided by negative 1 turns into positive 1. So my inverse, h inverse of x, equals negative x plus 1. All right, and then last one. Start by multiplying by 2. Divide by negative 5. And we get 2x over negative 5 equals y. In function notation, we get something like this. If you feel like you need more practice on just solving for inverses, I would encourage you to do this next page on the very back, and I will check it when I get back. For right now, though, I'm going to show you 3 examples. 3 examples of verifying inverses using composition. So this time I'm giving you 2 functions, f and g, and I want you to use function composition to determine if they are inverses. So I need to test 2 things. I need to look at f of g of x and g of f of x. And if when I do both of those compositions I'm left with just plain old x, I know I have inverses. So first one, f of g of x. That means I'm going to circle g of x and replace the x inside f. So I'm going to write 2 times 1/2 x minus 5 plus 5. I need to clean this up a little bit, so I'll distribute my 2. 2 times 1/2 x is 1x. 2 times negative 5 is negative 10, and you still have the plus 5. When I combine my like terms, negative 10 and 5 give you negative 5. From here, I can't simplify any further, and I did not get just plain old x. I got x minus 5. So from that point on, I don't even have to test this other composition. I just know that f and g are not inverses. Okay. Next one, same thing. I'm going to test f of g of x and g of f of x. So for f of g of x, I would have 1/3 times 3x plus 21 minus 7. When I distribute my 1/3, that's the same as dividing by 3. And then when I get to my combining like term steps, the 7 and the 7 go away, and I'm just left with x. So far I'm in a good spot. I'm going to test the other direction too, g of f of x. So this time I'm plugging f into g. I'll distribute my 3. And again, I'm left with just plain old x because the 21s are going to cancel out. So this time we get to write, yay, f and g are inverses. Okay. Then last one on this page. Again, given two functions, use composition to see if they're inverses or not. So f of g of x and g of f of x. For f of g of x, I would have this function being squared and then a minus 2. I know that squared and square root are inverses of each other, so they're going to undo each other, and I'm just left with the x plus 2 and a minus 2. X plus 2 minus 2 leaves you with just x. Going the other way, I have my square root of x squared minus 2 plus 2. So this time, the minus 2 and the plus 2 go away, and I'm left with the square root of x squared, which square root and squared cancel out, and you're left with just x. So again, you're allowed to write, yay, inverses. Okay. Notice too on this example how first the squared and square root canceled out, then the 2's canceled out, and over here the 2's canceled out, then the squared and square root canceled out. So if they're inverses, you should be getting rid of things in opposite orders. Now I want you to try this last page on your own, and I will check it and let you know how you did when I get back.